Last question, we're pros by now, right? So, how are we going to solve this? And I'm referencing the 3 previous videos, 1A, B, and 2A, in our strategy of how we solve this, which is, let's turn each equation into standard form, and then let's substitute into the other. Now, in this case, we might end up with some fractions and things, but that's fine. It's a nice opportunity to practice fractions, right? Okay, right, everything's a nice learning opportunity. But really, I actually believe that. So we've got our 2 graphs. We've got this graph here, 2x minus 3y equals 5. So let's rearrange this. I like to just rewrite it in my own hand to start with. Okay, now I'm ready to go. 2x minus 3y equals 5. How did we do these before? We got y's on the left, so let's subtract 2x. Let's subtract 2x. So minus 3y equals minus 2x plus 5. So I think it's worth putting it sort of in standard form already. The x's first. Remember, this was a plus 5. That's what it is. So that's why it doesn't matter the order, because we're just adding. And now we want just y, so we're going to divide that by minus 3. What we do on one side, we do on the other, and we do it to the whole of the other side. So we do it to each term. So that divided by minus 3 and that. So we've got minus 3y over minus 3. Well, that's why, because that's why we did it. Minus over minus is a plus. So we got positive 2 over 3x. Now notice, I prefer writing this as 2 over 3x rather than 2x over 3. Because if I asked you what's the gradient, you're going to tell me 2 over 3, right? Because that's mx, so this is the gradient. Okay, plus over minus is minus, and we've got minus 5 over 3. Cool, let's do our second one, and let's go, I'm sure somewhere over here there must be like an orangey color that could match that orangey color. Is that the right? I don't think I've matched the graphs up correctly here. Anyway, let's really just make sure it's a different color. 3x minus 2y equals 20. So our first step is, let's rearrange it so that it's in standard form. This is the point that we get to re-practice turning things into standard form. And from standard form, we can look at things like gradient and y-intercept. So let's go for minus 3x on each side. Okay, so we've got minus 2y equals minus 3x plus 20. Again, mx plus c. We're not there yet, but we're getting to that stage. Let's divide by negative 2 so that we have y. What we do on one side, we do to the whole of the other side. So we do it to that term and to that term, divide each of them. So we've got negative divided by negative is a positive. Again, I want to call this 3 over 2x rather than 3x over 2. So we can clearly see our gradient. And for this one, plus 20 divided by negative 2 is negative 10. So we can see what the y-intercept is. And now we're ready to answer the question. And the question asks us to draw a straight line. That was quite good. And to say, we're solving simultaneously. When are the 2 graphs? When are they equal to each other? This point that I've said, hello. There it is. Hello. And what are the coordinates of that point? So how do we do that? We're saying when this function is equal, that 3 looks terrible, right? 3. When is that equal to the other function? To 3 over 2x minus 10. It's an equation that we can solve, but conceptually, when are the 2 graphs equal to each other? We make them equal to each other. Okay, now we've got a bit of work to do with our fractions. So, number of ways. So when we've solved equations with fractions. And the way we solved it before was we said, let's find our LCD and then multiply by that. So let's do that strategy. I like to do the same strategy as far as possible instead of inventing new ways to do it, as fun as that is. So our LCD in this case, well, we've got summing over 3, over 3, over 2, over 1. So our LCD must be, what sort of 2 and 3? 6, I would say. So it's 6. So let's multiply that whole side by 6 is how we did it when we were doing those Khan Academy videos, and multiply that whole side. So when we multiply through 6 times this fraction, well, the 6 and the 3 cancel, so it's just timesing the top by 2. In other words, if we went 2 times the top, 2 times the bottom, we would end up with just 4x. And just check it. 4x, if we divided by 6, did the opposite, we'd end up with 2 over 3. Okay, minus 6 and the 3 are going to cross cancel because it's like 6 over 1. So minus 10, because we've multiplied that by 2 and we've multiplied that by 2. Okay, let's do the same on the other side. We're multiplying by 6. So in other words, we're finding our LCD of 6. So we're multiplying that by 3. We're multiplying the top by 3. So we've got 9x. Does that make sense? 9x over 6 is the same as 3 over 2. Okay, this one we'd need to multiply by 6. And we're going to have to do the same to the top. So we're going to go minus 60. Because 6 times negative 10 is negative 60. And the whole point of that was now we don't have those fractions, so it's a lot easier to solve. So from here, I'm going to subtract 4x, and add 60, so that we can have our equation such that we've got x on one side, and we've manipulated it such that we've got constants on the other, in other words, non-variables. Okay, 50 equals 5x. Decide to get colorful. Divide by 5 so that on the right-hand side we just have x, on the left-hand side 10. This matches our picture. X equals 10. But our first thought was the same. You're not going to get many that are going to be fractions at this stage. But it's a nice opportunity. It was there for a reason. Let's practice our fractions. Otherwise, we panic when we see them and we feel like we've done something wrong. No, we haven't. Fractions. Fractions are our friends. Just like brackets. Okay. So enough of that, right? X equals 10. Now, we need to substitute this into one of these equations. Either our first line or our second. You've got your calculator handy. So once you substitute it, you can try put in your calculator and go from there. But I'm going to choose 2. I'm going to write it out, and I want to ask you why you think when I substitute it, I've chosen this. If you don't want to use your calculator, this is going to cancel out, cross-cancel nicely. So the 10 and the 2 are going to cancel to give you 5. 5 times 3 is 15 minus 10 gives you 5. Does that match our picture? Yes, it does. Of course, I expect that you're just going to go 3 over 2 brackets 10 minus 10 gives you 5, and you're going to say, cool, that was 5. I don't know what he was on about. I just like to have the 10 and the 2 could cross cancel because this is 10 over 1, and we could do that. So our final point was x equals 10, y equals 5. Let's make that a nice 5, and we're good, right? Could do this, right? What is Mr. Evrod thinking? Happy things. Goodbye.